In less than 2 years since launching, the James Webb Space Telescope has changed the way we understand the universe. For scientists, the images it's taken offer new possibilities for astrophysics, and for the rest of us, they are simply stunning to behold.
Astronomers worldwide are amazed by a groundbreaking discovery. The James Webb Space Telescope captured distant city lights 7 trillion miles away, exceeding expectations. This expands our cosmic understanding, sparking speculation among scientists studying the data for clues about these celestial beacons. It suggests life beyond Earth, raising questions about extraterrestrial civilizations and life's likelihood elsewhere. Do these lights suggest alien civilizations? What does this discovery mean for life beyond Earth? Join us to unravel how the James Webb Telescope captured city lights billions of miles away from our planet. Launched on Christmas Day 2021, the James Webb Space Telescope has the goal of being a more advanced and powerful imaging device than the Hubble telescope. It has the purpose of acquiring the sharpest pictures of objects that have recently been identified, for example, planetary systems. Before going into what this finding is, let's look at the Hubble telescope's role in space exploration. The pioneering Hubble Space Telescope. The Hubble Space Telescope, HST, launched in 1990 and still operational, has transformed astronomy. A joint effort between NASA and ESA, it fulfills a dream from the 1920s made possible by technological advancements by the 1970s. The HST's main mission is to deliver high-resolution cosmic imagery. This enables detailed study of celestial objects, deepening our insights into galactic, stellar, and planetary formation and development. As a Cassegrain reflector telescope, the HST achieves the concentration of light from space objects by using mirrors. Its primary 4-meter, 7-8-foot primary mirror along with the smaller secondary mirror directs light to the focal plane containing instruments for image capturing and data collection. The Hubble has a lot of equipment that supports various observations of the universe. These devices include cameras that take objects of space shots, spectrographs that split the light into basic colors which are used for analysis purposes, and polarimeters that study light polarization to detect properties of celestial bodies. Astronaut servicing is among the design features of the Hubble Space Telescope. The satellite is on a lower orbit, which poses a more severe space situation for it, requiring from time to time repairs and instrument substitution. The first servicing mission in 1993 dealt with the defect of the primary mirror by attaching the corrective optics. A total of 5 servicing missions have been made, with the last one in 2009. The Hubble Space Telescope has transformed our view of the cosmos forever. It has offered breathtaking celestial object imagery and made groundbreaking discoveries. It involves, for example, figuring out the expansion rate, discovering dark energy, and watching the birth of stars and galaxies. Hubble's role doesn't just stop at its discoveries, but it also propels innovations in astronomical technologies and rouses another legion of scientists. This legacy has provided a base for the success of telescopes such as the James Webb, with the promise being deeper perceptions into the cosmos and the advancement of the knowledge of the history of the universe. The Deep Field Images, an objective of the James Webb Space Telescope, JWST, is to examine the most ancient galaxies and push the age of the universe to its most remote stages. Through the use of the solar system as a tool, it depicts the heavenly objects as their ancient ancestors could have seen them. Astronomers apply the light years, i.e. the quantity that light travels in 1 year, to specify these unthinkable distances. The group's first presentation highlighted this idea as they presented a deep field image launched on July 11, 2022, by President Joseph Biden at the White House. This image, in a way similar to the deep field from the Hubble Space Telescope, zoomed in into a tiny patch of sky and classified about 3,000 new objects, with the majority of them being distant galaxies residing billions of light years away. The JWST's deep field picture, just like Hubble's, displays a nondescript speck of the night sky. On the other hand, in this tiny area close to the SMACS 0723 galaxy cluster, there is a lot of data to be mined. This gigantic complex, a tremendous 6 billion light-years away, it functions as a natural magnifying glass due to its immense gravitational force. Named a cosmic magnifying glass, this phenomenon, therefore, enables us to dive deeper into the past, where we can reach as far as 1 billion light-years. This allows us to see the sparse glow of galaxies that were 800 million light-years away, and only a few hundred million years after the Big Bang. The immense distance of these background galaxies has a remarkable effect on the light they emit. The expansion of the universe itself stretches this light out, shifting it from the visible spectrum into the infrared range. This fortunate twist of fate allows the JWST, specifically designed to detect infrared light, to observe these ancient galaxies with exceptional clarity. By comparing these observations with visible light images captured by telescopes like Hubble, astronomers can begin to piece together the grand narrative of galactic evolution. This comparison offers a unique window into how galaxies have transformed from their primitive states billions of years ago into the majestic structures we observe in the present day. One particularly impressive aspect of the JWST's deep field image is the speed at which it was obtained. Remarkably, the telescope was able to capture this wealth of data in mere hours, showcasing its exceptional efficiency in galaxy detection. Furthermore, the magnifying power isn't exclusive to galaxy clusters. The JWST, on the other hand, captured a captivating image of two galaxies that are interacting known as VV191. When light from one galaxy travels through the other, it gets deformed, providing clues about the dust properties of the intervening galaxy. This newly discovered data has the potential to unravel novel secrets about the ingredients and evolution of galaxies. The reach of JWST is not just limited to exploring distant galaxies. A recent mystery on the official website is believed to be the possible sighting of northern lights on a brown dwarf, a celestial body that lies between stars and planets. This fact is so strange because brown dwarfs lack internal fusion processes that are responsible for star powering and aurora generation. Researchers are trying to establish the precise source of energy sustaining these auroras. Others propose an analogous mechanism to the Earth's auroras, where methane emissions combine with the brown dwarf's atmosphere. The development of this research can lead to, especially, a new understanding of these mysterious heavenly bodies. Supermassive black hole discovery. The supermassive black hole, the latest jewel in JWST's wondrous crown of findings, was recently detected. This large black hole, 40 million times bigger than our Sun, is eating its way through the neighborhood while being highly active. Found by Dr. Lucas Furto and AI Zetrin at Benan University in Israel, this black hole's enormity indicates its possible impact on its host galaxy's development. Thankfully, this supermassive black hole resides a safe distance away, a staggering 12.9 billion light-years from our solar system. Despite the immense distance, the JWST can still peer through the vast cosmic gulf to unveil its aggressive feeding behavior. The reddish hue detected by the telescope is likely caused by a thick veil of dust that engulfs the black hole, blocking most light from escaping. This dusty shroud also conceals the true size of the beast. However, when the JWST began transmitting its initial data, scientists were particularly excited about three small objects emitting a crimson glow. These objects might be quasar-like entities, supermassive black holes at the centers of galaxies actively devouring matter. The peculiar appearance of these objects, with their luminosity seemingly concentrated within a tiny spot, raises questions about their nature. Gravitational lensing, a natural phenomenon where massive objects bend light, provided precise size estimates. Even when compressed by the lensing effect, these black holes make up a staggering 1% of their system's total mass, hinting at their immense size. Similar behavior observed in other early universe supermassive black holes has shed light on their growth and their relationship with their host galaxies, although many aspects of this interaction remain shrouded in mystery. Fermi paradox. Apart from these groundbreaking discoveries, the JWST has also captured other intriguing phenomena. In one instance, An image released by the European Space Agency, ESA, showed a small orange mark resembling a flipped question mark at the base of a picture focused on two young stars forming some 1,470 light-years away. This peculiar shape, possibly due to the limitations of a two-dimensional image, has sparked curiosity among astronomers. Speculations extend from galaxies far apart to other not-identified factors. Nevertheless, there is a need for more research to determine the nature of this discovery, which could then be the platform for unlocking more mysteries of the universe. This focus on the unknown extends to the search for life beyond Earth. The vast number of distant galaxies unveiled by the JWST has ignited fresh scientific inquiry, particularly regarding a specific set of Earth-sized planets that might hold clues to the existence of extraterrestrial life in our cosmic neighborhood. This pursuit directly addresses the Fermi paradox, which questions the absence of evidence for advanced extraterrestrial life despite the high probability of its existence. One such star system of particular interest is TRAPPIST-1, located approximately 40 light-years away from Earth. This star system, where 7 of its planets are revolving around it, is now pivotal in the search for habitable worlds. In their search for physical planets, NASA factors in various parameters such as their size, distance from their host star, and importantly, the composition of the atmosphere. This latter aspect is evaluated through infrared measurements, like those conducted by the Spitzer Space Telescope, and helps assess a planet's potential to support life. Active M-dwarf stars. The JWST recently achieved a milestone by measuring the temperature of TRAPPIST-1b, the first detection of light emitted by an exoplanet of its size and temperature range. This breakthrough underscores the telescope's sensitivity and its potential to revolutionize our understanding of rocky planet atmospheres. Although these distant worlds are beyond our immediate reach for exploration, their characteristics offer valuable insights into planetary formation and potential habitability, despite the challenges posed by their proximity to an active M-dwarf star, TRAPPIST-1. The star system hosting these intriguing planets falls under the category of active M-dwarf stars. These are small, cool stars with a relatively low mass compared to our Sun. They belong to the M spectral class, which signifies their cooler temperatures. A defining characteristic of active M-dwarfs is their intense magnetic activity. This activity stems from the dynamic interplay between their atmospheres and their magnetic fields. The churning of these elements generates strong magnetic fields, responsible for the observed high-energy radiation. The magnetic field also creates powerful winds that carry away angular momentum, causing the star to slow down over its lifespan. Active M-dwarf stars are notorious for their frequent and unpredictable flares. These flares range from minor microflares to powerful high-energy events. They can significantly impact the surrounding environment, including any potentially habitable planets within the system. The energy surge from a flare injects tremendous energy into the star's atmosphere, resulting in a characteristic rise and peak in its brightness, known as the impulsive phase. The habitable zone around active M-dwarf stars is located much closer to the star compared to our solar system. This proximity translates to an increased energy flux from stellar events impacting potentially habitable worlds, often by an order of magnitude or more. This intense energy influx can have significant effects on the atmospheric equilibrium and surface conditions of a habitable zone planet. Modeling the impact of repeated M-dwarf flaring on the atmosphere of a potentially habitable planet is crucial for understanding the long-term effects of these stars. Scientists use sophisticated computer models that combine photochemical and radiative convective processes to investigate how repeated flaring alters a planet's atmosphere. The implications of active M-dwarf stars for life are significant. The intense magnetic activity and frequent flaring could remove the atmosphere of a planet completely, resulting in a hostile environment for living beings based on the knowledge that we have today. On the other hand, a planet that has a solid magnetic field might be able to divert the stellar winds and hold its atmosphere. As well as that, the powerful radiation of magnetically active M-dwarf stars can lead to dramatic changes on the surface of a planet, which may hinder the process of evolution. While the JWST's findings suggest TRAPPIST-1b lacks a substantial atmosphere and experiences extreme temperature variations due to its tidally locked rotation, these observations provide valuable insights into planetary dynamics around active stars. More importantly, they showcase the JWST's remarkable capabilities for probing countless more exoplanets, paving the way for a deeper exploration of exoplanetary atmospheres and the potential for life beyond our solar system. Wasp 43b discovery. Life on planets similar to Wasp 43b, which is also imaged by the James Webb Space Telescope, would probably not be able to survive in such severe conditions. This planet is designated as a hot Jupiter due to its large volume and the proximity to its star as sizzling as 1,250 degrees C, with extreme equatorial winds reaching a speed of 5,000 miles per hour. Wasp 43b's tidally locked nature condemns one side to a permanent day, enduring relentless stellar bombardment. Here, temperatures soar high enough to melt iron and most metals. The dark side offers no respite, remaining exceptionally hot at around 1,110 degrees Fahrenheit. This extreme temperature difference fuels supersonic winds that continuously circulate the scorching air. These violent winds prevent the formation of stable gases like methane, a vital molecule for life as we know it. Extreme temperatures, as well as the absence of steady and stable gases, and never-ending heat and wind, contribute greatly to the poor prospects of life on planet Wasp 43b. James Webb Space Telescope's remarkable precision while measuring the temperatures of such distant planets displays its unmatched sensitivity and stability. Notably, the absence of methane on Wasp 43b suggests that the ferocious winds, exceeding 5,000 miles per hour, prevent the chemical reactions necessary for its formation even on the cooler night side. Planet K218b. This harsh reality of Wasp 43b highlights the vast diversity of exoplanetary environments. In contrast, the JWST has also turned its gaze to K218b, a planet 8 times Earth's size orbiting a cooling dwarf star called K218, some 120 light-years away. This intriguing world resides within the habitable zone of its star, raising the possibility of liquid water and potentially life. Initial observations of K218b hint at the presence of a gas, dimethyl sulfide, DMS, that on Earth is often associated with biological processes. This tantalizing prospect has ignited speculation about the existence of ocean worlds, with vast oceans and hydrogen-rich atmospheres. However, the certainty of these findings awaits further analysis and peer review. More definitive evidence is needed to confirm the presence of DMS and understand its potential origins in K218b, the Voyager missions. Whilst the JWST reaches into the depths of distant planets, the Voyager missions are still astonishing scientists here in our solar system. Voyager 1, the probe that was launched in 1977, is encountering a mysterious region at the end of our solar system. This unpredicted journey adds another chapter to the great history of Voyager missions. In the beginning, their mission was supposed to be short, along with a vast amount of precious data and extended exploration for space science. Scientists' findings consistently act as a reminder of the never-ending importance of inquisitiveness and exploration. The start of interstellar space, according to scientists, is where the sun's magnetic field and the solar wind, which is a continuous flow of particles from the sun, stop. Voyager 1 made such a great achievement in 2012, while Voyager 2 flew at a distance of 11 billion miles from the sun in 2018. As the successors of the solar wind, the Voyager spacecraft have focused their research on the interaction between the solar wind and the heliosphere, the protective bubble encompassing the solar system. This interaction, affected by interstellar space conditions, creates the heliosphere dynamics. The Voyager missions are given credit for the invaluable knowledge that NASA gained regarding interstellar space. What is more, they found out that cosmic rays, high-energy particles coming from outside our solar system, are about 3 times stronger past the heliopause, the barrier beyond which the heliosphere lies. This sets the stage for a deeper understanding of the interactions between our Sun and the immense interstellar matter between the stars. Voyager 1, going further into interstellar space, recorded the sound of swishing caused by waves of trace gas in the interstellar medium. Despite operating in temperatures significantly lower than initially planned, the Voyager probes continue to yield valuable scientific data. Voyager 2's plasma instrument, still operational during its 2018 heliopause crossing, provided a clearer view of the boundary, revealing changes in plasma behavior near this critical zone. Both spacecraft observed intriguing phenomena at the heliopause. Voyager 1 encountered tendrils of interstellar particles reaching into the heliosphere, while Voyager 2 detected a thin stream of low-energy particles extending past the heliopause. These observations challenged previous assumptions about the smooth disintegration of the solar bubble and revealed a distinct boundary marked by sharp changes in plasma density. Further intrigue arose from the consistent distances between the Voyagers at the heliopause, despite differing solar activity levels during their passages. Additionally, Voyager 2's measurements revealed a less complex heliopause with lower energy particles compared to Voyager 1. These discrepancies highlight the nuanced nature of heliopause and the need for a more comprehensive understanding. The Voyager's data has opened a Pandora's box of questions. While coronal mass ejections, bursts of solar plasma, are a familiar phenomenon within our solar system, the Voyagers showed their reach extends beyond the heliopause, influencing cosmic ray flux in interstellar space. This influence extends even further, as supernovae immensely powerful stellar explosions send shockwaves throughout the galaxy, potentially shaping the very environment where our solar system formed. This raises the possibility that the Sun's activity may have influenced the emergence of life not just here, but on other worlds as well. Since cosmic rays can trigger biological mutations, the Voyager's insights may illuminate how the Sun's heliosphere interacts with interstellar space and other planetary systems. However, our knowledge remains limited. With only 2 data points from the Voyager heliopause crossings, a more complete picture of the heliosphere's structure and dynamics is needed. While both spacecraft exited near the leading edge, the vast wake of the heliosphere, its shape and interaction with interstellar space, remains largely unexplored. Challenges the Voyagers are facing. While present-day missions like New Horizons are journeying closer to the heliopause's outer edges, the necessity for more interstellar travelers becomes more apparent. Voyager's energy sources, RTGs, are like nuclear batteries in their slow decline, emphasizing the necessity of continuous missions. Voyager 2's prolonged mission through creative energy-saving measures demonstrates a level of commitment to extracting maximum scientific benefit from these iconic probes. Aboard Voyager 2, a malfunctioning chip casts a shadow. Theories range from energetic particle damage to simply succumbing to the harsh realities of operating for 46 years in space. While Voyager 1 focuses on cosmic rays, a puzzling anomaly dubbed Pressure Front 2 Inches has captivated scientists. This region, characterized by heightened plasma density and a stronger magnetic field around the spacecraft, remains an enigma, a product of the Sun's influence or a phenomenon of interstellar origin. The question lingers unanswered. Troubleshooting on Voyager 2 revealed an issue during a routine maneuver intended to calibrate its magnetic field instrument. The inability to complete the maneuver resulted in increased power consumption, further straining its limited resources. As Voyager 2's power source relies on heat generated by decaying radioactive fuel, this fuel's gradual decline translates to diminishing power output. To prioritize critical functions, non-essential systems, including some scientific instruments, are deactivated when power levels dip. Unfortunately, the rotation maneuver mishap left Voyager 2's scientific equipment dormant, hindering its ability to gather crucial data. Despite these challenges, a team on Earth, separated by a daunting 17-hour communication delay each way, successfully restarted Voyager 2's instruments. This triumph allowed the spacecraft to resume its mission of exploring interstellar space and gathering invaluable scientific data. Technical glitches can ignite speculative narratives. In the case of Voyager 2, communication glitches fueled conspiracy theories, suggesting aliens tampering with the spacecraft. However, such claims lack substantial evidence. The more plausible explanation remains technical issues within Voyager 2's systems. Beyond technical glitches lie the mysteries of deep space. A recent study explored the possibility of receiving responses from distant stars to signals sent by NASA spacecraft. Analyzing transmissions from Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons, researchers identified potential interactions with other stars. These interactions raise intriguing prospects of intelligent extraterrestrial life, encountering and responding to our signals, potentially initiating communication with Earth. The study's findings indicate a possibility of hearing back from advanced civilizations around white dwarfs by 2029, offering exciting prospects for interstellar communication. Venus's toxic atmosphere. Closest to home, a recent discovery has created excitement for Venus, our neighboring planet. A NASA satellite has just discovered something out of the ordinary between Earth and Venus, thereby confusing whether it is an alien encounter or something related to gravity. Scientists can't wait to solve the riddles of this area. The echo is expected from these incidents by 2033, in conjunction with Voyager 1's maneuvers. The crew has discovered that in the year 2341, the ship will have accessed 277 stars, besides the first one star in 2044. At the same time, other studies have identified certain signals of life in Venus's atmosphere, an atmosphere that was once believed to be uninhabitable. Some scientists refer to this as a result of non-living chemical processes. However, many remain doubtful and look through the window of new possibilities such as atmospheric and geological phenomena. The finding leads to a rethinking of Venus's past, arguing for a period in history when it may have been more like Earth. It tests how planets within our solar system evolve. Several scientists agree that Earth wasn't always as favorable for life as it is now. In the early years, it might have fostered a biosphere conflicting with its oxygen-rich environment, which evolved later on. Instead, Venus became a desolate environment, while Earth thrived and became the home for a variety of life forms. Today, Venus serves as a cautionary tale, a planet whose atmosphere is mostly carbon dioxide and whose surface temperature reaches about 800 degrees Fahrenheit. The atmospheric pressure on Venus is 90 times the sea level's density, which is equivalent to the pressure of water at a depth of 3,000 meters. These extreme conditions make Venus a hard place to attend, even with many robotic missions in history. Despite the harsh environment, some spacecrafts have captured images of Venus's surface. Beneath its scorching exterior lies a cloud layer with surprisingly Earth-like temperatures of 86 degrees Fahrenheit and pressure. This has led some scientists, like Carl Sagan and Harold Morowitz, to speculate about the possibility of life on Venus. In 2017, astronomers like Jane Greaves took this idea further. Using powerful telescopes, researchers like the James Clerk Maxwell Telescope in Hawaii searched for chemicals on Venus, including phosphine. This molecule, consisting of phosphorus and hydrogen, was unexpectedly found in the Venusian atmosphere. While phosphine can form naturally in extreme environments like Jupiter, its presence on rocky planets like Venus and Earth is intriguing. It raises questions about potential life forms, particularly anaerobic microbes, that might be capable of producing it. The detection of phosphine has sparked discussions about extraterrestrial life. This gas is commonly associated with certain anaerobic organisms on Earth, challenging our understanding of habitable environments and opening doors to new astrobiological exploration. Interestingly, phosphine is also produced by deep-sea worms and has various other applications. It's a highly toxic substance used in chemical warfare and as a fumigant on farms. Pop culture even features phosphine. The TV show Breaking Bad depicts the main character using it as a weapon. However, despite these diverse uses, the exact mechanisms by which Earth's bacteria produce phosphine remain a mystery. Geoscientist Matthew Pasek highlights a crucial distinction. While phosphine has been linked to microbial activity, a direct link between microbes and its production hasn't been definitively established. We don't fully understand where it comes from or how it forms, Pasek says. We've seen it associated with microbes, but we haven't observed a microbe directly producing it. It's a subtle but important difference. Atakama Large Millimeter Array Journey. In March 2019, the Atakama Large Millimeter Array in Chile trained its sights on Venus, revealing significant concentrations of phosphine, far exceeding Earth's levels. This hinted at a potential source on Venus itself. Computer simulations of the Venusian atmosphere showed that the phosphine needed constant replenishment as it breaks down under light exposure. Volcanic activity and lightning couldn't explain the observed levels, hinting at a biological origin. This finding aligns with a recent trend of detecting potentially biogenic gases on other planets. However, alternative explanations exist. Although the existence of phosphine on Venus is confirmed, the particular nature of the life that could produce it is still a topic of debate. According to Dr. Seeger and her team, microbial life in Venus's acidic clouds could be the culprit, since they might have originated from the planet's ancient oceans that were later ejected into the atmosphere due to changing conditions. At the same time, researchers emphasize the importance of not solely ascribing the phosphine to extraterrestrial life. Moreover, the extra data from various space telescopes and possible future missions to Venus would also help in the discovery of this secret. However, Venus's unexpected role in the search for life beyond Earth only strengthens the argument for exploring the solar system's varied ecosystems, hinting at an astounding universe filled with wonders. Mars exploration is not only about the search for life, but it's also about the comprehension of life's commonness within our solar system and beyond. By investigating extraterrestrial extinction events, such as the one that turned Venus into a hellish desert, researchers are given a glimpse into how the Earth might end up and the impact we will leave behind. These puzzles nurture scientific curiosity and extend knowledge horizons. We've seen this before with the Moon. Once thought to be a simple celestial body, Apollo missions revealed a complex history. The discovery of a northosite, a unique lunar rock type, challenged existing theories and hinted at a violent event in the Moon's past. These revelations highlight our ongoing quest to understand our celestial neighbors and our origins, the ninth planet, and the search for intelligence. Our search for life extends beyond our solar system. Astronomers like Adam Frank and Gavin Schmidt ponder whether Earth might hold traces of past, non-human civilizations. Besides, the search for a ninth planet in the remote regions of our solar system is still ongoing due to anomalous gravitational forces. These cosmic puzzles make us eager to learn and motivate us to go on adventures to explore the unknown. Countless suns host rocky worlds like Earth, and even lone planets roam the galaxy unattached to any star system. Recently, astronomers discovered a massive but faint brown dwarf with a Venus-like planet orbiting it. This unique find, observed through gravitational magnification, could offer insights into planetary formation and the search for potentially habitable worlds, including moons that could support life or Earth-like planets. While this discovery doesn't definitively prove anything, it hints at a possible universality in how celestial companions form across different scales, according to Andrew Gould from Ohio State University. Planets and moons typically form from spinning disks of material surrounding newborn stars, a process believed to have also shaped Jupiter's largest moons. Brown dwarfs, though not quite stars themselves, play a role in this cosmic dance, influencing the creation of celestial bodies like the recently discovered Venus-like planet. The study of exomoons, moons orbiting planets, or brown dwarfs outside our solar system is particularly important in the quest for habitable worlds. Understanding their size limitations relative to their host planets or brown dwarfs helps astronomers determine potential habitability. Although our solar system's large moons are too distant from the Sun to support surface water, exomoons around distant gas giants may be closer to their parent stars, creating conditions conducive to life. However, the likelihood of finding habitable planets resembling Venus around cold brown dwarfs is low due to their lack of heat from fusion. The detection of the Venus-like planet around the dim brown dwarf relied on a method called microlensing, which poses challenges for further research. While microlensing can detect faint stars and their orbiting planets, analyzing their atmospheric properties for habitability assessment remains a hurdle. Thank you for watching another episode. What are your thoughts on these latest discoveries on the possibility of extraterrestrial lives in our universe? Do you agree that they exist? Let us know in the comments below. See you next time.